Okay, so I want to kind of talk about the worksheet and how to use the relationship chart that goes with this. The relationship chart is not something that you're going to be given. It's something that you need to be able to generate on your own. I just gave it to you because sometimes it's hard to figure out how to set them up. And I discovered a number of years ago that it's not common sense. I kind of thought it was, but it was not. So, what you have is you have three basic functions that you worry about. You have f of x, you have f prime of x, and you have f double prime of x. All right, so things that you're worried about as far as what f of x is doing. You're worried about where it is increasing, decreasing. You're worried about maxes and mins. You want to know where it is concave up. You want to know where it's concave down. And you want to know where your points of inflection are. Fine. So, where this is increasing, that would be positive. Where this is increasing, that's negative. Maxes and mins are the zeros, or where it doesn't exist. Okay. And then concavity has to do with the second derivative. So where it's concave up, this is positive. Concave down, this is negative. Points of inflection, these are your zeros, or your does not exist. Fine. The way you fill out this part is you have to keep in mind that the relationship between the first and the second derivative is that the second derivative is the first derivative of the first derivative. So where the derivative of something is positive, this would have to be increasing. Where the derivative is negative, this would be decreasing. And then when you have zeros and does not exist, that's the maxes and mins. So that's where the chart is coming from. You just then have to figure out how to translate it into drawing the graphs that they're asking you for, or into listing the information that they've given you. So I gave the answer keys for it so you can look at it, but I wanted to sort of talk you through this chart that you should have, okay? So realistically, this first page of the worksheet you're doing twice. First time around, you pretend that they're the functions and you have to sketch the derivative. Second time around, you pretend that they're the derivative and you want to sketch the function. So really, I would do the whole worksheet the first way and then do the whole worksheet the second way. I wouldn't switch back and forth the whole time. So, when you are pretending that it's the function and trying to sketch the derivative, you want to write down where these things happen and then draw a picture that does this. Okay? So then when you're doing it the second time around, you want to write down where these things are happening and then draw a picture that does that in the corresponding spots. Okay? And you're just sort of estimating your intervals. It doesn't have to be perfect. So if I was doing it the first time around, picture is increasing here and there. So that is, say, -1 to 0 and 1 to infinity. So then you're decreasing everywhere else. So you've got from negative infinity to -1 and from 0 to 1. So in terms of your maxes and mins, you've got them at 1, 0, and 1. Fine. You've got concave up from negative infinity to, say, there-ish, to like -1/2. And then again from, say, 1/2 to infinity. So when you're concave down, -1/2 to 1/2. Your points of inflection Notice I'm not actually concerned with y values for any of this, okay? So then you need to know how that translates. So then here's where it's got to be positive, negative, 0 or does not exist, increasing, decreasing, axes and minutes. And you just have to make a picture that does that. And again, you don't want to be super concerned about your y value. So if you start out negative infinity, so you need to be negative and increasing until you hit negative a half. So you're negative, and so zeros or does not exist. So I'm going to put them in the zeros. That doesn't work out. Let's see if asymptotes would make more sense. So you want to start at negative, and you increase until you hit negative a half. Flip around and you decrease until you hit positive a half. Flip around and increase, and then you have to make sure that your positives and negatives are right. And that's all you do. Okay? It takes practice though, and some of them are easier than the other ones. So then let's say we're trying to do it the second time around. So that's where you're looking at the second row of the chart and making it do the first thing. So you want to talk about where it is positive, negative, zeros, or does not exist, but that one exists the whole time. And then you want increasing, decreasing, and maxes and mins. So let's see, positive, you're looking at negative infinity to, I don't know, say negative 1.2. Negative a half to a half. Let's get 1.2 to infinity. Negative would be everywhere else. So you're looking from negative 1.2 to negative a half. A half to 1.2. We've got zeros at negative 1.2, negative a half, 1.2. Increasing. Negative 1 to 0, 1 to infinity. Decreasing, negative infinity to negative 1, 0 to 1. Maxes and mins are at 0 to 1. Okay. So positive means to be increasing, negative decreasing, zeros are maxes and mins. Increasing is concave up, decreasing is concave down, maxes and mins are points of inflection, which really aren't conscious things that you necessarily draw. And when you have the derivative and you're trying to sketch the original function, you don't worry that much about where the y's are located. So like if I have a sketch that centers around here and your sketch is way up here, it's fine. You don't worry so much about the y values. So, I'm just looking. So you need to start out increasing and concave down. And from 1.2 to negative a half, you're decreasing. And you want to make sure that here, unless you're decreasing, you need to start to curve it back around. Half, half. So, and then here you're increasing again. Half to 1.2 increasing again. What you should notice is that the concavity usually kind of works its way through when you do this. And then, okay, 1.2 to infinity, you have to run an increase more. They're not perfect. Because really, I should turn it around faster. And then that's what it ends up sort of doing. But that's how you have to do the whole worksheet. It takes time and patience and just keep working at it and reading through the descriptions, because it will overall help you to understand the relationship between the graphs quite a bit better.